In MCQ 9, this is with regards to copper being a metal, and this is once again a chemical bonding question. Now, copper being a metal, they did mention it consists of a lattice of positive ions in a sea of electrons. Drawing it out, we will see cation layers. And what is surrounding them could be regarded as the sea of mobile electrons. Now you can refer to this as delocalized electrons or free moving, it's fine. And because the charges are actually opposite, the attachment of the sea of mobile electrons towards the cation layers itself is actually strong electrostatic forces of attraction. And it require a large amount of heat just to overcome them. Some additional details for pure metals is that if a force were to be applied, the cation layers have the ability to slide over one another, and this gives rise to the first characteristic of malleability. And with the sea of mobile electrons present in both solid as well as molten state, metals are able to conduct electricity efficiently. And the strong electrostatic forces of attraction will be the reason why it has a very high melting and boiling point. So investigating the options that was given, looking at what is actually correct. Copper conducts heat because the positive ions are free to move. Now the conductivity of the heat of your copper has nothing to do with the positive ions, but everything to do with regards to the sea of mobile electrons. So 1 is actually wrong. Number 2, copper conducts electricity because the electrons are free to move. This is definitely true with regards to the sea of mobile electrons. Copper ions are held together because of their attraction for each other. This is negative because the ions are cation ions, which are all positively charged. They are not held from cation to cation, but rather from cation to the sea of mobile electrons. Lastly, copper having a high melting boiling point is partially true, but the reason for that of strong covalent bonds is not correct because this must have been due to the strong electrostatic forces of attraction between the cation layers and the sea of mobile electrons. And with that, we'll conclude that the answer for this question here is D.